Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve some questions on loss of kinetic energy. And the first of all, we are going to solve a question from paper 9709/41 for the session May June 25. And you can see on the screen, we are going to solve question number 5 from this mentioned paper. Let's read question number 5. When a particle P of mass mkg has speed u meter per second, its momentum is 4 Newton and its kinetic energy is 16 joule. Find the value of m and the value of u. So let's start our solution. In the question, it is given that momentum is 4 Newton. So we can start with this solution, with this information that momentum is given 4 Newton, and we know that momentum is the product of mass into initial velocity. So we can write mu or mu is equal to mass into initial velocity is 4. we can we will have to utilize this information later on. That's why we are leaving at this stage. Okay, and they have given one more information that kinetic energy is 16 joule. So we can write kinetic energy is equal to 16 joule, and we know the formula of kinetic energy is half of mass into v square. There is no necessity of putting this multiplication symbol mv square, and right side is 16. Well, after that, how much is our, if we look at the question, it is mentioned that speed is u meter per second. Okay, so initial velocity and final velocity is in this case actually same. That's why instead of a v square, we can write m mass into initial velocity into another initial velocity, because as speed has been mentioned, that means final and initial velocities are same. This is 16. Okay, now if we want to use this same information, let me write just beside this, or if we utilize the information from the previous one, let it be left as equation number 1. Okay, so half of mu is equal to 4 from equation 1. So let us write 4, then u, again another u, and our right side is as usual 16. Now look at this. If this 4 is divided by 2, it is going to be 2u. So 2u is equal to 16. What does it mean? That our initial and final velocity was 8 meter per second. 8 meter per second. Well, we have got one of the values. They have told us to find the value of u as well as m. Now, substituting this value of u in equation 1, we get that mu is equal to. So, hence, we can write here, hence, mu is equal to, in the equation number 1, mu is equal to 4. Okay, or u has already been obtained, so it's 8m. 8m is equal to 4. If 8m is equal to 4, our m must be zero point 0.5, because 4, if 4 is divided by 8, it is going to be zero point 0.5. Okay, and we are not supposed to use this unit because already they have given, look at the question here, they have already given you meter per second. So these meter per second should not be shown over here. Okay, so let us erase this. So finally what have we got? Our u is 8 meter per second and our m is zero point 0.5, which is the second part of the solution. That's all about answer to the question number A. Let's move on to question number B. Question number B says P is now projected on a smooth horizontal surface with speed v meter per second directly towards a particle Q of mass 1.25 kg, which is stationary. After P and Q collide, the velocity of P is w meter per second and the velocity of Q is 2w meter per second. The loss of kinetic energy in the collision is 25 joule. Find the value of V and the value of W. So it's all about loss of energy, and since the question number B belongs to conservation of momentum, we are not solving this right now. We are going to, our today's topic is actually loss of energy. So let's see, the immediate next question is about loss of energy, and as solution to B belongs to conservation of momentum, we will solve this solution, or we will solve this question in the topic when we discuss momentum of conservation. Let's see question number C. But I think as both the topics are related to each other in the same question, it is better we apply the concept of the conservation of momentum, and finally we will found the loss of energy. So let's start with the conservation of momentum. And you know, the concept of the conservation of momentum is ma into initial velocity, not a, it is actually first particle was p. So mp into initial velocity of p plus mq, the other particle, and initial velocity of particle q is equal to final velocity mass of particle p into final velocity of particle p, as well as initial velocity mass of particle q into final velocity of q. Now we are going to substitute the values. The mass of particle p is, let us see what is the mass of particle p. It is written mass of particle p is mkg. Okay, and we have just obtained the value of m as 8. Okay, sorry, not 8, m was 0.5. Look at this, we have obtained here m is equal to 0.5. So mass of particle p is 0.5 and mass of particle q is given over here 1.25. Okay, so we have got the values of the masses of particle p and q, and initial velocity of p was, we have already obtained, initial velocity of particle p was u meter per second. No, it is not u, because we are dealing with a different scenario. Here initial velocity of particle was v meter per second. Okay, and initial velocity of q was, it was stationary. Okay, q was stationary, means 0, and after collision final velocity of particle p was w, and the final velocity of particle q was 2w. So one after the other we are going to apply the values. The first one is mass of particle p, as we have seen it is 0.5 into initial velocity of particle p is, it is written w, sorry, not w, it was, it is v. Okay, so v plus mass of particle q is 1.25, and initial velocity of particle q was 0 because it was stationary. Look at this, here it is written stationary. Q was at stationary level. Then mass of particle p is 0.5. Then final velocity of particle p was w plus mass of particle q is 1.25, 1.25, 1.25 into final velocity after the collision. Final velocity of q was 2w, 2w. Now if we simplify, it is going to be 0.5 b on the left side. On the right side it is, look at this, 0.5 w and 2 into 1.25, that is 2.5, so it is 3w, 3w. Or v is equal to, if we transpose this 0.5 to the right side, 3 divided by 0.5 is it going to be 6w. So final velocity is 6w meter per second. Okay, v is equal to 6w meter per second. This is the information we are going to apply in the concept of the loss of kinetic energy. Now we can write loss of kinetic energy is given as loss of kinetic energy of kinetic energy kinetic energy is equal to 16 joule, sorry, 25 joule. Look at this, the loss of kinetic energy given is 25 joule, so we have formed an equation with this. Now we know the formula of loss of kinetic energy is change in kinetic energy of the first particle. Change in kinetic energy, the name of the first particle is p, and minus change in kinetic energy of the particle q. There are two particles, they have collided, that's why both of the particles should be considered. It is 25. Okay, and the formula we know about that change in kinetic energy, the formula of change in kinetic energy is actually half m v square. So negative half m, then m of which one, mass of particle p, then v square, minus change in kinetic energy is equal to the same concept, the mass of particle q, then v square, and our right side is 25. Okay, now let me see what to write the next part. On the right side we can continue writing. Let us substitute the values we do have. Or half means, you know, negative zero point 0.5, and mass of particle p is already we have used, which is also zero point 0.5, so 0.5, and v square. Yes, this is the crucial point. Remember, v square means it is not only one velocity. V square means the difference between the final velocity, square of the final velocity as well as initial velocity. So this is not one of the velocities, this is the difference between the final and initial velocity. So let us see what was the final velocity of particle p. Final velocity of particle p is given, look at this in the question, what is given, final velocity of particle p was w meter per second. So we will write final is W meter per second, and initial was what? Initial has been used. It was actually V. So initial velocity was V. We are talking about P, and final velocity was W for P. So remember, V square means final velocity minus initial velocity. Final velocity was W. So let us write W square, and initial velocity was V square. We have written first quantity minus the second one also goes, so half is zero point 0.5, so zero point 0.5 into mass of particle q was 1.25, and final velocity of q was, let's see what was the final velocity of q. The final velocity of q was 2w. It is given as 2w. So we will write 2w square. 2w square means 4w square minus initial velocity. Initial velocity of q was actually 0. Look at this. Initially q was at stationary level. It is written which is stationary. It is written over here q was in stationary mode. So there was no motion, hence we can write here 0. This is 0 for q. So remember, for loss of kinetic energy, our concept is final velocity minus initial velocity, and our right side is 25 here. Now if we continue our solution, it is going to be, if we multiply zero point 0.5 into zero point 0.5, it is going to be 0.25, 0.25, 25. Then W is equal to what? Look at this. Our V has been already obtained. V is equal to, in equation number 1, or in the first part of this solution, we have found our V is equal to 6W. So it is going to be 6W square means, sorry, W square, V is equal to 6W square. So 6W square means actually 36W square. So this is the first part. Then if we multiply zero point 0.5 by 1.25, zero point 0.5 into 1.25, it is going to be 0.5 into 1.25, it is going to be 0.625. So 0.625 into 4w square into 4w square, 4.625 into 4w square. If we multiply by 4w square, is equal to 25. 25 is our right hand side. Well, now what is it going to be? From 36, if we subtract 1, it is going to be 35 w square. So if you multiply 35 by 0.25, it is going to be 8.75, 8.75 w square minus 4 into 0.625, it is going to be 2.5. 2.5 w square is equal to 25. 25. Now you may raise a question that whereas this minus symbol went to, if we multiply this minus symbol with this minus symbol, it is getting positive, because 36 is greater, so it will be negative, negative, positive. And on the in the next quantity, actually there is nothing in front of negative symbol, so it will remain positive. Now from 875, if we subtract 250, it is going to be it is going to from 8, so 6.25, it is going to be 6.25 w square is equal to 25. Then if we divide 25 by 6.25, it is going to be actually 4. Okay, so w square is equal to 4. Hence our w is 2, because final velocity, they were in motion, it was not in negative. We are picking up the positive result since w is more than 0. Look at this, it was written that after the collision the velocity of q was 2 meter per second. Okay, so it was moving onward. Actually, when they collide each other, there is no to way for q to go back, so definitely this is positive. Okay, so w is positive. Now w is 2. The other value we have to find is v is what? From here if we look, v is equal to 6. Here v is equal to 6w, hence our v is going to be, let us write, hence v is equal to 6 to the what? 12. V is equal to 12. So these two are the answers we should show. And that's all about the solution to this question of paper 41 9709 slash 41 for the session May June 25, question number 5. This is whole of the solution at a glance. Now we are going to solve another question based on loss of kinetic energy. The next question we are going to solve is from paper code 9709 slash 42 for the session May June 25. And we are solving question number 2, which belongs to the same topic we are discussing today. Let's see what the question says. It says two particles P and Q of masses zero point 0.2 kg and zero point 0.1 kg respectively are free to move in a straight line on a smooth horizontal plane. P is projected towards Q with speed 5 meter per second. At the same instant, Q is projected away from P with speed 2 meter per second. When P collides with Q, the particles coalesce. Find the kinetic energy lost during the collision. Well, let's start the solution. And as there is a collision, we should know the velocity before the collision and after the collision. And the components of loss of energy or loss of kinetic energy is the difference between the velocities. So we should know first of all the initial velocity as well as final velocity of the two particles. So let's start our solution with application of the conservation of momentum to know the velocities initially and finally. Conservation of momentum is mass of particle p into initial velocity of p plus mass of particle q into initial velocity of q equal to mass of particle p into final velocity of particle p plus initial mass of particle q into final velocity of particle q. So let us substitute the values. If we substitute the values, mass of particle p is 0.2 and whereas q is 0.1, and initial velocity of p was projected towards q with 5 meter per second, so it is 0.2 into 5 plus mass of particle q is 0.1, and it at the same instant q is projected away from p. Away from p means actually it is to the same direction as p was moving on. So the initial velocity of q is 2 meter per second. Now mass of particle p is 0.2 and final velocity after the collision. Look at this, the both the particles coalesce means both of them were moving together being one single particle. That's why it is neither p nor q, it is simply we are going to find the final velocity as v. And mass of particle q is zero point 0.1, as both of the particles coalesce means got together, so their velocity is also same. Now on the left side, if we calculate 5 into zero point 0.2 is 1, 1 plus zero point 0.2, so that is 1.2, 1.2, and right side is going to be zero point 0.2 v plus zero point 0.3 v, so 0.3 v. If we divide 1.2, I mean 12 by 3, it is going to be 4. Hence, our V is equal to, let me write just beside this. Hence, our velocity is going to be 4 meter per second. That means after the collision, both the particles moving onward together at the speed of 4 meter per second. Now we are going to find loss of energy. So let us write loss of kinetic energy. Loss loss of kinetic energy, kinetic energy equal to, we already come to know the formula of kinetic energy from the previous solution. Let us write just beside this equal to negative symbol. Remember, whenever loss of energy occurs, then we will use negative symbol. Change in kinetic energy of particle, first particle P, minus change in kinetic energy of particle Q, means the second particle, equal to, if we use this equation, not equation actually, so equal to, it is going to be, let me write equal symbol over here. Okay, negative symbol. And what is the formula for change in kinetic energy? We have applied in the previous solution. It is negative 1, I mean half, mass of particle P and velocity, difference between the initial and final velocity, square of the velocities, minus again the second one, mass into mass of the second particle q, and final difference between the initial and final velocity. Let us substitute the values. It is going to be negative 1, I mean half, mass of particle p was 1.2, so it is going to be zero point 0.2, and final velocity after the collision of particle P was, we have obtained, it was 4 for each of the particles. So 4 squared, final was 4. Initial velocity of particle P was, this was the initial velocity, minus 5 squared. So is the next part, minus half, and mass of particle Q is zero point 0.1. So let us write 0.1. Final velocity of particle Q was 4. It was applicable for each of them because after the collision, each of the particles, both of the particles form a new particle whose velocity was 4. So 4 squared minus initial velocity of particle q was 2 meter per second. So 2 squared. 2 squared. Well, then let us calculate this. Look at this. 5 square means 25. From 25, if we subtract 16, it is going to be 9. And if we divide this zero point 0.2 by 2, it is going to be zero point 0.1. 0.1 into 60 and 60, I mean 16 minus 25 means minus 9. So it will be positive because both the minus, this minus symbol will multiply this minus symbol, so it is positive now. Well, after that, minus, if we divide zero point 0.1 by 2, it is going to be 0.05. 0.05 into 16 minus 4, it is 12. So if we simplify more, we will get zero point 0.9 minus, if we use our calculator directly it will show. Let me use our calculator. If we use our calculator it will show that zero point 0.9 minus zero point 0.6, so it is actually 0.3 joule is the loss of energy we have found. They have told us to find the loss of energy, which is zero point 0.3 kilojoule. So that is all about the solution to the second question of the same topic. Let's see one more question. The next question we are going to solve is from the paper 9709/43 for the session May June 25. Let's see what the question says. It says we are solving question number 1, and it says two particles P and Q of masses 0.1 kg and zero point 0.3 kg respectively are at rest on a smooth horizontal plane. P is projected directly towards Q with speed 4 meter per second. At the same instant, Q is projected directly towards P with speed u meter per second. After P and Q collide, P moves with speed 2 meter per second and Q moves with speed 4 meter per second. Question number A says find the two possible values of U. Solution number U belongs to conservation of momentum, as already we solved two questions applying the conservation of momentum. In this question we are not going to apply the concept of the momentum, conservation of momentum. We will directly go to our today's topic. Our today's topic is loss of kinetic energy. So for loss of kinetic energy, initial and final velocities are the components, and from question A we have got that we have solved it in another session actually, but the value of u is 14 meter per second. So let's start our solution with this one. U is equal to, let us write here, u is equal to, we can write here from a from from a our u is, there are two values obtained in A. One was U is equal to 10 as well as 14 meter per second. Let us write whether we should write unit or not. It is yes. U is 10 as well as 14. 10 as well as 14. Now look at this. The question number B says find the largest possible loss of kinetic energy. For largest possibilities, we will have to know that as there are two values of initial velocities, so if the initial velocity is larger, we will choose the larger initial velocity, because we can write here for for larger initial velocity, for this is not the solution to A, remember we are solving solution to B. So this I think I should not write over here, I should write at B. Let this comment be written: for larger velocity, for larger initial velocity, larger initial velocity, for larger initial velocity, the loss of energy is also larger. The loss of energy is also greater. Okay, that means if the initial velocity is larger, then after the collision loss of energy will also be greater. Now we are going to apply the concept. We know the loss of energy. Formula for loss of energy is change in kinetic energy. So let us write loss of energy is equal to loss of loss of kinetic energy. Kinetic energy is equal to negative symbol change in kinetic energy. Change in kinetic energy, as there are two particles P and Q. Change in kinetic energy in P minus change in kinetic energy of Q. Okay. Then if we apply the formula, we know what are the formula. The formulas are half m v square. Okay. So let us write equal to half negative half m mass of particle p and difference between the final and initial velocity of p minus half of, so is q mass of particle q and mass of particle q and difference between the final and initial velocity. So let us substitute the values. It is negative zero point 0.5. Okay, zero point 0.5, and mass of particle p is, already we have come to know mass of particle p was what, 0.1. One was 0.1, another one was 0.3. Okay, so we are going to write 0.1 and final velocity of particle p. This is also given in the question. Final velocity of particle p was, look at this, 2 meter per second for P, and for Q it is 4 meter per second. So let us substitute these values. The final velocity was 2 meter per second, so 2 square. Remember, we use v square means final velocity, square of final velocity minus square of initial velocity, minus initial velocity. Now let's see what was the initial velocity of p. Initial velocity of p was, it is written initial velocity of p, this initial velocity of particle p was 4u. Okay, and initial velocity of particle q was only u. So for p it is 4u, and we know we are going to apply u is equal to 10. So 4u means 40. Sorry, we are going to apply u is equal to 14. So it is 414. 414 means 56. It is going to be 56 squared. Okay, please don't get confused that how is it 56 square, because for initial velocity of p, once again I am showing, initial velocity of p is 4u. So if u is 14, so 14 into 4 means 56. That's why for p initial velocity was 56 meter per second. So we have written here 56 square, then minus zero point 0.5 for particle q, and mass of particle q was 0.3. We have already seen it was 0.3, 0.3, and the final velocity of particle q was, it was u, means 14. 14 square, sorry, final velocity of particle q was, let us say once again, final velocity of particle q was 4 meter per second. Look at this, it was 4 meter per second. So let us write 14 square, 14 square minus initial velocity was u square for q, so it is not 14, it was actually 4. Final velocity was 4. and initial velocity was 14 for q. So let us write 14 square. Okay, now if we simplify this, we will get equal to 56 square minus 4 square. Let us multiply all of this. In the first case, look at this minus symbol, this symbol and this symbol, they are getting together positive. So let us calculate using calculator. Using calculator, we got that our result is here positive 156.6, 156.6, 156.6, and here also the greatest symbol is negative, so it is going to be positive. And if we multiply 0.15 into 180, it is 27. 27 plus 27, and if we add up these two quantities, it is going to be 183.6 joule if we round it up to three significant figures. So that's all about this question, and that is the final question of today's session. And I tried my level best to explain the concept, that means loss of energy or loss of kinetic energy. It is simply that is change in kinetic energy of one particle and change in kinetic energy of the other particle. But the most important part is v square. In v square, always we will have to write the final velocity first. It is actually v square means final velocity square minus initial velocity square of each of the particles. Okay, that's all about the solution. So thank you all for being with me, and may Allah bless all of us with the beneficial knowledge. Allah Hafiz. Fi amanillah.